So welcome to 2.5, one infinite or no solutions. All right, so up until now, every equation you've had has had one solution. It turns out that's not always the case. There are equations with more than one solution or no solutions. Today, there's really only three choices, but there are equations with two solutions and three solutions and things like that. But today's equations will have one solution like they normally do, or infinite solutions. It means every number makes it a solution, or no solutions at all. All right, when we have no solution or infinite solution occurs when x is on both sides. But this is the warm-up. This should be ones from yesterday. So let's remind ourselves. We want to get rid of where x is fewer. So we have 7x equals negative 84. Divide both sides by 7, and x equals negative 12. Here we have, on number 2, we have combining like terms and x on both sides. You want to combine your like terms first, generally. Negative x minus 5x, negative 6x. Negative 1 minus 5 is negative 6. Once you have all your terms combined, then you want to look where there are fewer. Well, negative 6 is a smaller number than 3, so we're going to get rid of where there are fewer. Notice we're not adding 6, we're adding 6x to both sides. Make sure you write it that way. There's our two-step, add 59 to both sides. 59 plus negative 14 is in fact 45, positive 45. Divide both sides by 9, and 5 equals x. Does every equation have one solution? No. In fact, this one has infinite solutions, which means every number makes it true. So let's start with ones that have no solution. This only will occur when x is on both sides of the equal sign. So let's see that. So we have 4x plus 18 equals 4x plus 5. So what would you do here? Well, we're trying to get rid of the x's and get them on one side. But what happens? Well, there's the same amount of x's on both sides. And so, right, 4x minus 4x is 0 on both sides. And what do you get? You get 18 equals 5. Well, when you try to solve an equation that has no solution, you're going to end up with an equation that isn't true. So don't leave that. Let's say 18 does not equal 5. And what you're going to do when that happens, you're going to say there's no solution. And what that means is there is no number that I can put where x is to make this all work out. There is no solution. Try this one. So we're going to combine our like terms there, and we get negative 6x plus 7 equals negative 6x plus 2. Notice we have the exact same amount of x's on both sides. Now don't stop there because the standard says you have to finish these. So you add 6x to both sides, right? Make them both 0. And we get 7 equals 2, except that's not true. And so you get no solution. Now, this one has same amount of x's on both sides, but has infinite solutions. And let's see that. So we're going to subtract 5x from both sides. And you get 8 equals 8, right? On the last screen, you got weird things like 6 equals 8. Now that's true. And this is called an identity. When you have the exact same thing on both sides, both of these are in fact called identities. When you have the exact same thing on both sides of an equal sign, it's called an identity. But that's not what you write on your homework. On your homework, when this happens, you're going to write infinite solutions. And what that means is every single number you put in there will make this true. All right? You could also write every x is a solution. Try this one. So when it looks like that, you can see it right away. That's going to happen. But usually it's disguised. Let's see what happens here. So we combine our like terms here. Whoops, the like terms aren't there. The like terms are here. Negative 14 minus 2. So this is 3x minus 16. 8x minus 5x is also 3x. So we have an identity. We have the exact same thing on both sides. So just finish it off. Get rid of the x's on both sides. And so that's true. And so we write, when that happens, we write Right? The answer is not negative 16. The answer is that there are infinite solutions. All right, so which of the following are solutions to the equation? Choose all that apply. All right, let's see what happens. Let's try to solve this. So we have 7x plus 21 equals 7x plus 21. Oh, we have an identity. And so when we try to solve this, right, we're going to get infinite solutions. So what does that mean? It means all of those will make it true. That's the point here. You would circle all of them. Any number you put in this equation will make it true. Okay, let's try this one. Solve it, please. Well, x is smaller than 5x, so we're going to subtract the x from that. And you get 4x minus 13 equals negative 13. Now we're going to add, so this is not an identity. It does not have infinite solutions. Let's see that. And so we're adding 13 to both sides. We get 4x equals negative 13 plus 13 is 0. Divide both sides by 4, right? What is 0 divided by 4? It is 0. So how many solutions is that? That is one solution, right? Students are tempted to say that means no solution, but it doesn't. There is a number, a solution that will make this true. If you put 0 in there, 5 times 0 minus 13 equals 0 minus 13, right? Because you get that, and you get negative 13 equals 13. So 0 is a solution. It is one solution. All right, so one of the things I told you the other day was typically we distribute this fraction first. But one of the standards is that you should be able to look at other people solve things and understand what happens. So you could distribute this 1/4 like we already learned, but you also could get rid of this, you could clear the fraction right off the bat. And so you could multiply this entire side by 4 and that entire side by 4. And so you can just, in a textbook they would actually, and I should too, they'd put parentheses around that whole thing. You're multiplying that entire side by 4. And what happens there is that by just multiplying this 1/4 out there, you have done that. All right, you've canceled that 1/4, and now you just get 3x minus 6. And this side, you get 9 times 4, 36. Add 6 to both sides. 3x equals 42. Divide by 3. 3 goes into 42 14 times. Okay, so you could have distributed and gotten what? I'll do it the distributive property way up here. It's 3/4 x minus 6/4, 1/4 times 6, equals 9. And then you could have multiplied everything by 4. And when you do that, you'll get the exact same equation we got. So you're allowed to do this if you want. All right, so same thing here. So what would you multiply both entire sides by to clear those 1/2 and 1/3? Well, you could multiply by 6, right? 3 won't get rid of the 2. 2 won't get rid of the 3. But you could multiply both sides by 6 to get rid of the whole thing. And so let's see that. So the 2 cancels with the 6, and that becomes a 3 out there. Now that 3 is still out there. This 3 cancels with this 6 and gets a 2, and so that 2 is still out there. But we have cleared our fractions right off the bat. All right. So now we could do distributive property. 9x minus 15 equals 2x plus 4. Get rid of the x's that are fewer. 7x minus 15 equals 4. Is that right? We have add 15 to both sides. 7x equals 19. Divide both sides by 7. X equals 19/7, also known as 4 and what? 5/7? Not 14. 4 and 5/7. And you don't want to make any time, you don't want to make sevenths into a decimal. All right. Now, if you distribute the fractions first, you will get the exact same answer. I'll do that up here quickly. 1/2 times 3x, 3/2 x. 1/2 times 5 minus 5/2. 1/3 times x, 1/3 x. 1/3 times 2, 2/3. You would still have to multiply everything times 6 to get rid of all the fractions. And hopefully you would get right? That would become a 3, and that would become 9x. And now we get the minus 15. I'm getting the exact same equation as there. And that would be the 2x, and that would be the 4. All right, so you have options now. That's what this screen is about. Just describing that there are other ways to do these problems. The truth is, as long as you do everything to both sides correctly, you can never mess up. But you have to, you know, as long as you do everything correctly. You can do things different ways. All right, so do both these practice problems and then check your work. Right? This has no solution. None of those will make it true. Okay, so let's clear some decimals, right? So on these practice problems, all right, work on clearing fractions and decimals, then check your work. All right, we haven't had one of these. So what is the only number you can put where that question mark is to make that have infinite solutions? All right, well, let's, first of all, let's get rid of this and do distributive property. All right, so we could add 9x to both sides, just show that. So we have 30 equals 9 plus this question mark. So what did the question mark have to be? The question mark has to be 21 in order for that equation to have infinite solutions, right? For infinite solutions, x has to disappear, right? So there can't be any x in the question mark. And we have to have the exact same numbers on both sides. So it has to be 21. Thank you.